22. ఏం డిస్కస్ చేస్తున్నాం మనం? లిమిట్ సెట్ ఇన్ఫినిటీ, లిమిట్ n టైమ్స్ టు ఇన్ఫినిటీ గురించి మాట్లాడుతున్నాం, అంతే కదా? ఓకే, సరే. వాటిలో ఫస్ట్ వన్ చూడాలి ఇప్పుడు, అంటే నెక్స్ట్ బిట్లో లిమిట్ x టైమ్స్ టు ఇన్ఫినిటీ a పవర్ x గురించి మాట్లాడాలి. సో ఆలోచించండి ఒకసారి, లిమిట్ x టైమ్స్ టు ఇన్ఫినిటీ a పవర్ x వాల్యూ ఏమవుతుంది? ఫస్ట్ బిట్ a గురించి చెప్తున్నాను, చూడండి ఒకసారి. If you have any doubts, raise your hands. So just now we discussed that limit x tends to infinity a power x is different depending on the values of a. But among those, one important thing is limit x tends to infinity a power x is 0 if 0 less than a less than 1. Among all those discussions, this is somewhat more helpful in solving different problems. Okay? If base is in between 0 and 1, then its limit value is 0. Now, let us consider the second problem. Limit n tends to infinity q power n plus p power n to the power 1 by n. And one restriction is also mentioned in the problem, that p is less than q. See, whenever p is less than q, you just think about it, p by q is less than 1. So p by q value is less than 1. See, just treat that p comma q as positive also. Okay, that is not mentioned in the question, and we need to consider p less than q as well as pq are positive. Since pq are positive and p by q is less than 1. Okay, now just observe this problem. This is equals to limit n tends to infinity q power n plus p power n to the power 1 by n. From these two terms, you just pick out q power n. So q power n of 1 plus p power n divided by q power n and whole to the power 1 by n. Okay, and then this is equals to limit n tends to infinity q power n power 1 by n, which can be written as q power n to the power 1 by n into this 1 plus, see, this is p by q to the power n and whole to the power 1 by n. So limit n tends to infinity q power n whole power 1 by n into 1 plus p by q power n to the power 1 by n. So this is equals to limit n tends to infinity q power n power 1 by n is simply q, and whereas in this case this is 1 plus p by q to the power n whole to the power 1 by n. So as we are applying limit n tends to infinity, write this q outside. So q into 1 plus this p by q is less than 1 as well as both are positive. That in the sense p by q value is in between 0 and 1. Since p by q is in between 0 and 1, as n is tending to infinity, so that a power x format. So this p by q base is in between 0 and 1, power infinity will give you 0. So 1 plus 0 to the power infinity, 1 by infinity. Okay, so 1 plus 0 to the power 1 by infinity. So that is equals to q into 1 plus 0 is 1 to the power 0. So 1 power 0 is just 1 and your answer is q at the end. Once you just have a look, as n tends to infinity, we need to think about q power n plus p power n to the power 1 by n. Direct replacement of infinity is not acceptable. Why? Because we don't know about p and q, they are just positive. They may be less than 1, they may be more than 1. So in that case, when you replace infinity directly, it is somewhat an indeterminate task. because the base must be, the may be infinity and the power is 0. Infinity power 0 is also not acceptable. It's an indeterminate form. So to avoid that indeterminate form, we need to go with some logical process. And here is it. What it is? So q power n plus p power n, just common out q power n. So q power n of 1 plus p power n by q power n and whole to the power 1 by n. Okay. So now we just apply this 1 by n for both the terms. Q power n power 1 by n into 1 plus p by q to the power n power 1 by n. This value is q and this is 1 plus p by q to the power n whole to the power 1 by n. See, this q is a constant which is independent of n, so write it out and apply limit n tends to infinity. Since p by q is a number which is in between 0 and 1, its power n is 0. So 1 plus 0 to the power 1 by infinity. So this is 1 and this is 0, 1 power 0 is 1 and your answer is q. Have a look, that's second bit B. And then I will solve C and D. Okay, have a look. So next one is limit n tends to infinity 3 power n minus 2 power n divided by 3 power n plus 2 power n. When you directly replace infinity, if you replace infinity directly in the place of n, it will give you an indeterminate form. How it makes indeterminate? 3 power infinity, 2 power infinity, infinity minus infinity, and here it is infinity plus infinity. Everything is indeterminate actually. But to avoid that indeterminate, we have a logic here. How to solve it? Just have a look as the first point. If the base is in between 0 and 1, limit extends to infinity, a power x is 0. So with that idea, you need to make an exponent whose base is in between 0 and 1. For that, you need to common out 3 power n from numerator and denominator. Just like picking out the highest degree term, for this type of problems, you need to pick out highest value base term. So this is equals to limit n tends to infinity. So 3 power n of 1 minus 2 power n by 3 power n is numerator divided by 3 power n of 1 plus 2 power n by 3 power n is denominator. So you just cancel out this 3 power n and 3 power n. Then the problem will become like this. This is equals to limit n tends to infinity 1 minus 2 by 3 to the power n is numerator, 1 plus 2 by 3 to the power n is denominator. As n is tending to infinity, replace directly n with infinity. So 1 minus 2 by 3 to the power infinity divided by 1 plus 2 by 3 to the power infinity. This 2 by 3 is very smaller value, which is a decimal value in between 0 and 1. When you raise its power to infinity, the value still becomes 0. So 1 minus 0 divided by 1 plus 0 is equals to 1 is your answer. So when direct replacement, direct substitution gives you indeterminate form, to avoid that you need to use some logical skill of mathematics, and here I applied in this way. Have a look and then try the next problem. So another problem, last one of this model, okay. So limit n tends to infinity 3 into 2 power n plus 1 minus 4 into 5 power n plus 1 divided by 5 into 2 power n plus 7 into 5 power n. Just I note there. See, as I said for the previous problem, to solve this type of problems, we need to pick out an exponent whose base value is more, okay. So this is equals to limit n tends to infinity. From these two terms, you just pick out 5 to the power n plus 1. Okay. So this is 5 to the power n plus 1 into 3 into 2 power n plus 1 divided by 5 power n plus 1 minus 4. Okay. Just pick out that 5 power n plus 1 from both terms of the numerator. And again from the denominator, you just pick out 5 power n from both terms of denominator. So this is 5 power n into 5 into 2 power n divided by 5 power n plus 7. Okay. I think you all know the way of picking out, right? And now this is 5 power n plus 1, this is 5 power n. So there is a simple way to cancel it out. So this 5 power n and it cancels this for 5 times. So in the next step, what we need to, how we have to do? This is equals to limit n tends to infinity 5 into 3 into 2 by 5 to the power n plus 1 minus 4 divided by, in the denominator, 5 into 2 by 5 to the power n plus 7, that's the denominator. Just have a look, n is tending to infinity. As we noted, if n tends to infinity, a power n is 0. As you rise the power, if the base is a number which is in between 0 and 1, the value becomes smaller and smaller. Here 2 by 5 is such small number which is in between 0 and 1. But we are rising its power to infinity. N tends to infinity means n plus 1 also tends to infinity. So this term will become 0. 3 into 0, or you may say directly 0. So this is equals to 5 into 3 into 0 minus 4 divided by, and in the denominator 5 into 0 plus 7. When you solve, you will get your answer as minus 20 by 7 for this particular problem. Okay, have a look. So just look at the board. Limits at infinity. Limit x tends to infinity. So to solve these type of problems, this is very useful line. Okay, useful comparison between different functions. When you look at all these things, okay, logarithm of x to the base a. So logarithmic function and x to the power n. This is what an algebraic function usually, x power n. See, when you consider logarithmic function and exponential function, as you rise the value of x, as the value of x is more and more, logarithm value will become smaller when compared with the x power n. Okay. See, for very larger values of x, the a may be any number, n may be any number, no problem. But if x is very large, for sure logarithm of x base a is smaller when compared with x power n. And in the same way, when you compare x power n and a power x, if x is very large in the sense the value of x may be 10 crores, 100 crores, 1000 crores, crores of crores, and very large, in those situations this x power n value is lesser when compared with the a power x. A may be any number, n may be any number, but x is very large. Okay, so this x power n is very small when compared with a power x. And as well, a power x is again very small when compared with x factorial if that x is a natural number. X is a natural number and that x is very large, then in that case you just compare a power x and x factorial. A power x is very small when compared with that x factorial because x is very large. So just to discuss this line, graphs will help you more, and you just try to memorize this particular line to answer different problems. Okay, so let us look at this first problem. Limit x tends to infinity x power 2020 by x factorial. X is tending to infinity. That in turn represents that x is very large. Since x is very large, x power 2020 means this type of function and x factorial is that type of function. This x power n format is very small when compared with that x factorial. That in the sense very small value is dividing with very large value. That in the sense almost we are dividing a value which is nearer to 0 by a larger value. Okay, and that in turn represents your answer as 0. Okay, you just think about it once again. This numerator is not 0, but the numerator is very smaller when compared with the denominator. Actually, as x is tending to infinity, x power 2020 is also larger quantity. But when you compare with x factorial, then only this value is smaller. So this is smaller when compared with x factorial. Though that smaller value divided by this x factorial will gives you 0. Okay. In the same way, we can answer the remaining questions also. E power x divided by x factorial. E power x is just like a power x and that is x factorial. This is smaller value, that is larger value. Smaller by larger gives you 0. And again 3 power x by log x to the base 7. See, log x to the base 7 and 3 power x is this type of function. This logarithmic value is very smaller. That a power x value is very larger. We are dividing larger value with this smaller value, then the value is infinity because the numerator is larger and the denominator is smaller. Then x power 5 by 3 power x. The same discussion. X is very large. As x is very large, x power 5, this type of function is smaller than this type of function. Since this is smaller, numerator is smaller, denominator is larger, when you compare these two with one another, the numerator is very smaller than the denominator, then in this case the value is 0. Is it clear? In the same way, actually, for suppose if I have a problem like this, limit n tends to infinity for some 4n plus 3, okay, it just look like an algebraic, right? Divided by, you may take any number like 2 power n. See, the numerator is linear and the denominator is 2 power n. This 4n plus 3 is just of this format actually, okay? Or otherwise, if you have any confusion here, just take it as x tends to infinity, 4x plus 3 by 2 power x. You just split it, 4 into x by 2 power x plus 3 by 2 power x. As x is tending to infinity, this 2 power infinity is larger, so this 3 by 2 power infinity is almost 0. See, this 2 power infinity is larger, so 3 by infinity is almost 0. When you think about this, as x is tending to infinity, this x and 2 power x, comparison between these two types of functions. This numerator is very smaller when compared with the denominator, and that's why this value by 2 power x is again 0. So 4 into 0 plus 0, at the end your answer is 0 for this type of problems also. Just to answer these type of problems, just to decide the limit value, whether it is 0 or infinity, this comparison between different functions is very helpful. So try to memorize it. Log x to the base a is very smaller when compared with x power n. And that x power n is again very smaller when compared with a power x. A power x is again smaller when compared with x factorial. This comparison directly gives you answers like this, 0 and infinity. Okay, have a look. So, at the end, once again look, see, this comparison helps us to solve these problems. And in this comparison, actually I mentioned here as a greater than 0, but it's a wrong thing, okay? A should be greater than 1. If a is greater than 1, then only this comparison is comfortable and possible, okay? So, you just rewrite this 0 as 1 and then memorize it and then try to attempt these questions, try to give the answers directly, okay? That's it for the class. And this is limits at infinity of third class, okay? You need to follow the previous classes again to be perfect at the limits at infinity. And that's for today's class. Thank you. Do like the video as well as you share for your fellow aspirants. Thank you.